Understanding atoms, how they fit together in materials and how their electrons behave, was the final key to understanding the fundamental nature of electricity.
This is a Wimshurst machine, and it's used to generate electric charge.
Electrons are rubbed off these discs and start a flow of electricity through the metal arms of the machine.
Now, metals conduct electricity because the electrons are very weakly bound inside their atoms and so can slosh about and be used to flow as electricity. Insulators, on the other hand, don't conduct electricity because the electrons are very tightly bound inside the atoms and are not free to move about.
The flow of electrons, and hence electricity, through materials was now understood. Conductors and insulators could be explained. What was more difficult to understand was the strange properties of semiconductors. Our modern electronic world is built upon semiconductors and would grind to a halt without them. Jagadish Chandra Bose may have stumbled upon their properties back in the 1890s, but no one could have foreseen just how important they were to become. But with the outbreak of the Second World War, things were about to change.
Here in Oxford, this newly built physics laboratory was immediately handed over to the war research effort. The researchers here were tasked with improving the British radar system.
Radar was a technology that used electromagnetic waves to detect enemy bombers. And as its accuracy improved, it became clear that valves just weren't up to the job.
So the team had to turn to old technology. Instead of valves, they used semiconductor crystals. Now, they didn't use the same sort of crystals that Bose had developed. Instead, they used silicon. This device is the silicon crystal receiver. There's a tiny tungsten wire coiled down and touching the surface of a little silicon crystal. It's incredible how important a device it was.